Well, good morning, students. Yes, I got up at 4, took a shower. I actually got my hair dried finally. That took forever. Got my coffee, and we're ready to rock and roll. I know what you're thinking. Who in their right mind gets up at 4 o'clock in the morning and is this freaking happy? Thank you, Duncan. Actually, believe it or not, that was the first sip of coffee I've had all day. We're ready to do after school day 2 review. Oh my God. Wait, it's in the morning. How can it be after school? Day 2, solving trig equations, trig formulas, a little bit with trig graphs today. A little bit with trig graphs. Not a lot, but a little bit. We're ready to rock and roll, rolling, rocka. Oh, you know what I need? Hold on, let me pause. I'll be right back. I forgot to go find the formula sheet. Want to make sure I had that. Make sure you have that formula sheet available and ready to go. So we're ready to rock and roll. All right, let's just go. Oh, you couldn't hear me when I'm drinking my coffee. Oh, crap, sorry. By the way, when we're going through these problems and you haven't done them yourself, first of all of these problems can be found at my website. Go to www.mrkrausmath.com. Let me show you where you need to go. Go to www.mrkrausmath.com. That will give you a little countdown to when the Regents exam is on June 17th. It's at 3, you have 39 days, 2 hours, 25 minutes, basically 39 days. Go to Regents Review. Now, if you're working with, and you want to do all the Regents exams are right here. All the old Algebra 2 Trig Regents exams are right here. You get a copy exam, you get a copy of the multiple choice answers, and you get my video solutions for all of them in a nice organized fashion. But if you go to Algebra 2 Regents topic reviews, right now, we only have day 1, logarithms and exponential functions. But as soon as I finish this video, I'll post it up online, and you can get the review notes, and you can watch the video. So it'll be here next time. By the time you're checking it, it'll be there. All right? So that's that. Let's get back to work. I know you're excited. All right. So, can I zoom in a little bit so you can see? All right. Here we go. So, if sine of b equals 2/5, what is the value of cosine 2b? So we're just going to be random stuff all over the place. Now, you need to understand that if you see this, cosine 2b, sine 2b, or tangent 2b, or of course not to be, then you have to go to the formula sheet. You don't have a choice. You have to go to the formula sheet, and you're going to look for the double angle formulas. Double angle, in your case, means 2a, 2x, 2 theta, whatever, 2 something. Now for cosine, you have 3 choices right here. 3 choices. You have to make a wise decision. Now they gave us sine, so it wouldn't make sense to use cosine sine. It wouldn't make sense to use just cosine. It makes sense to use this equation right here, which just has sine in it, and it's 1 minus 2 sine squared a, whatever a is. Now, you don't have to memorize this. You just have to know where it is and how to use it. Eventually, someday, you'll memorize it. Maybe. So, we're going to use the formula that cosine of 2b is equal to 1 minus 2 sine squared. Now, they used a on the formula sheet. We're not going to use a. We're going to use b. So, sine squared b. Now, wait a second. That's difficult to look at. You have to remember that when you have a sine squared like this, what this really means is this. It really means, oops. Oh my God, I just erased half the stuff. Hold on a second. And we'll go back to blue. What it really means is this. Sine of b squared. Sine of b squared. So, what is the sine of b? We're going to replace the sine of b with what it's equal to. So, in here goes this. So, now we're going to rewrite this as 1 minus 2 2/5 squared. And then we come over to the calculator And we go to calculator. By the way, I'm using TI Inspire. It's a great calculator. Hopefully you have one. If you don't, I'm going to tell you right now, it's well worth the investment to get it. Squared. And 21 over 25. Now, having said that, there is another way to do this problem. It's sometimes tricky. What you could do is find out what b is equal to. So if I could do control, oh, excuse me. Yeah. Shut up. All right. If I do sine inverse, of 2 divided by 5, I'll get the angle measure. And then I can do cosine of 2 times that answer. And I probably should get it, but I just don't know if it's going to give me the exact answer. I think it's going to give me some decimal approximation. Yeah, see, 0.68. Now, can I approximate that to fraction? I don't know. Number, approximate to fraction. Will it work? Nope. It's not going to be exact. It's off a little bit. It's off quite a bit, actually. So maybe that's not such a good idea. Let's just do it this way with the formula. Which trig equation does not simplify? Wow. So this one's going to go back to you remembering a few things. Wow. This is a tough question. All right, so let's take a look at each equation. There are probably 3 functions you should know. There's 3 things you should probably remember. Okay, so there's 3 trig identities you probably have to have memorized. One of them is cosine squared x plus sine squared x is equal to 1. The other one is tangent squared x plus 1 is equal to secant squared x. And the last one is cotangent squared x plus 1 is equal to cosecant squared x. Now this one lends itself to 2 other equations, and that is cosine squared x is equal to 1 minus sine squared x. You should have gone through this with your teacher. And sine squared x is equal to 1 minus cosine squared x. Now so this one gives rise to 2 other equations that are sometimes useful. And then these 3 have to be memorized. So anyway, let's see what we got. Let's do this one up here. So this is really sine squared x times 1 plus cotangent squared is right here. It's cosecant squared. And cosecant squared is really sine squared. So this is sine squared x times 1 over sine squared x. The sine squared x's cancel and you end up with 1. So that one simplifies. Let's try this one. Let's come back to that one. I think that one, man. All right, let's do this one. This is secant squared x. Let me do it in a different color. Let me get some more space here a little bit. So I'm going to do it down here. Do it in purple. So it's secant squared x times, now 1 minus sine squared x is really cosine squared x. And secant is 1 over cosine squared x times cosine squared x over 1. These cancel, and I end up with 1. So it's got to be one of these 2. Now, tangent squared x. Oh my gosh, Cortana, get off my case. I don't have anything specifically for tangent squared x. So I'm not going to deal with that one right now. But I do have something for secant squared. I know that secant squared is tangent squared plus 1. So if I do this, cotangent squared x times tangent squared x plus 1 minus 1. That's this thing here became these two. And then I did minus 1. So this becomes cotangent squared x times tangent squared x, because the ones just cancel. And this is cosine squared x over sine squared x times sine squared x over cosine squared x. And those cancel, 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 and that makes 1. So the answer is this one. This one's kind of tricky, so let's see what we got here. I can come up with something for... No, I don't even have anything for tangent squared. Well, tangent squared is equal to... If I brought this 1 over, it would be secant squared minus 1. So this could be secant squared x minus 1, but that's just minus 2, and that's not a problem. So this is the answer. The other ones simplify. Ooh, that was a tough one. So the point 0, -4 is a point on the terminal side of theta. What is the cotangent of theta? So all of this is just telling you where to put your angle line. So let's just graph that point 0, -4. 0, -4. 1, 2, 3, 4. So it said that it's on the terminal side of theta. Well, if you remember correctly, this has to be the initial side, always along the positive side of the x-axis. And if we're going in standard position, this is the way the angle would go, and we go here. So this angle right here, this point right here, gave us the fact that we got this angle, this ray, because it said that the point 0, -4 is on the terminal side. Terminal side. So all of this work was to just get 270 degrees. Now you have to know what the cotangent of 270 degrees is. Or you can just use your calculator. Cotangent of 270 equals -5.5. Wait a second. What am I doing? Oh, my calculator's in Radian mode. I knew something was wrong. Let me get out of this Radian mode. I knew that wasn't supposed to... It's too early. I don't have enough coffee in me. That one... this one should turn out to be 0. Oh my gosh. 0. There's your answer. The answer is 0. Make sure your calculator's in degree mode. So, is this basically the same question? Oh, it's boring. I'm going to change the point. We're going to go... I don't know why I just did that. We're going to change the point to -4, 0. Just to make things a little more interesting. So, I don't know. Maybe -4, 0 then will be over here. So, if my angle was on the terminal side of that... There's the original side, or the initial side. There's the terminal side right there. And I would go, and I go, oh, we have 180 degrees. So now I'm going to do the cosecant of 180 degrees. Now this is going to be interesting. This should give you an interesting answer. Cosecant of 180 should crash. Oh, it says undefined. Oh, that's easy. It's undefined. And the reason for that is because it's really... the sine, it's 1 over the sine of 180. And I hope by now you understand that the sine of 180 is 0. So 1 over 0 is in fact undefined. Determine the nearest degree, minute, and second. The measure of the angle of 3 pi over 5 radians. So we've got 3 over 5 pi radians. So what we need to do is to convert this to degrees. So we're going to multiply by 180 over pi. All right, so the pi's cancel. So I get, what I end up with is 540 over 5. And we're going to turn that into degrees, minutes, seconds. So let me get my calculator out. I don't know why you're up there. So I'm going to do 3 divided by 5 times 180. It's probably going to give me that 5. Oh, all right, so whatever. So what did they say, 108? Yeah, it's 108 degrees, but what? Determine the nearest minute, the degree measures of an angle of 3/5 pi radians. It's exactly 108 degrees. Zero minutes. That's really a dumb question. Am I doing this wrong? All right, I guess that's right. All right, I'll be back. All right, kids, let's keep going. Oh my gosh. I don't think I'm on the right page. There you go. Wake up, bro. All right, now I've completely lost it. Oh, there it is. Man, I lost my... There we go. Man. Oh, it's like too much, not enough contrast. There we go. All right. The area of parallelogram is 684, and the lengths of the sides are 32 and 26. Determine the nearest 10 minutes, the measure of the angle, the acute angle of the parallelogram. So if you draw a parallelogram in, you get this, and it says the sides are 26 and 32, and I always draw it like this. So it said that the area is equal to 684. Now the only area formula you're going to be given is this one over here. But that's the area formula of a triangle. Well, if you think about a parallelogram is really just two triangles. So if we want the area formula of a parallelogram, we just get rid of the half. And that gives us our area formula of the parallelogram. So we're going to use that formula. And we're going to say, okay, 684 is equal to 26 times 32 times the sine of x. All right. Well, we'll divide by this, by whatever this is, 26 times 32. We'll do that in our calculator. So 600 and, well, I don't even remember the number. 684, 680, control division, 684 divided by 26 times 32, 26, oops, come on. Gotta wake up. I don't even have the right number in the top. 684 divided by 26 times 32. Boom. That. 171 over 208. I know that bothers you all, but it's okay. Equals sine x. Now we need to, anytime you're looking for an angle, the last step is inverse sine. Bring the sine over, change the sign. It's inverse sine. So we're going to take inverse sine of that weird thing. And it said to round it to the nearest 10 minutes. So we got to DMS this thing. So we go in our catalog. We don't see it, so we click on the D for DMS, and we go down, 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 down. Oh my gosh. There it is. We're going to DMS it, degrees, minutes, seconds. So it's 55 degrees, 17 minutes. So it's x equals... Why am I not having a hard time? All right, so 55 degrees, 17 minutes, doesn't really matter, 49.6 seconds, 49.6 seconds. Now, they told us to round it to the nearest 10 minutes. Now, 10 minutes is this thing. So we have to decide, do we want it to be 55 degrees, 20 minutes, or 55 degrees, 10 minutes? So is this closer to 20, or is it closer to 10? And since it's closer to 20, we're going to do 55 degrees, 20 minutes. And there's your answer. All right, given the function graph below, determine what the amplitude is, what the frequency is, and what the midline is. Should do. And a possible equation for this. Okay. Now, I know I asked for the amplitude first, but that's not what you should be finding first. The first thing you should find is the midline. The max is 4. And the min is -2. So in between them is 6. So we're going to go up 3. So the midline is right here. Y equals 1. y equals 1. I hope my head's not in the way. So when I'm creating my equation, it's going to be y equals, I didn't even look at it to see what kind of equation it is, but I know at the end we're going to have a plus 1. Now, I can also now determine that it's also going to be a cosine function because we're starting up here. So we'll get there. So my amplitude, it's starting up 1, 2, 3. So my amplitude is 3, and it's a cosine function, and it's starting up. So it's positive 3 cosine. Now I just have to decide what the frequency is. So remember, frequency is how many full cosine curves in 2 pi. Not how many they showed you, it's how many in 2 pi. Well, this is a full cosine curve. And it finished that in pi. So it finished 1 in pi. That means its frequency is 2. And that means here goes 2x. Done. Moving on. Solve for all values theta to the nearest degree. All right. Remember what I told you before. If you see this, I don't care if it's cosine, sine, or tangent, you have to go to your formula sheet. And in this case, there's only one choice for that. And it's 2 sine A cosine A. So we're going to come back and replace it. So cosine theta minus 2 sine A. We're going to use theta though. Sine theta cosine theta equals 0. Now at this point, lots of kids crash because like, I don't know what to do. I don't know what to do. Just GCF. We got a GCF. So we're going to take out a cosine theta. That's gone and that's gone. But remember, there's really a 1 sitting right here. So it becomes 1 minus 2 sine theta equals 0. Already, set them equal to 0. Cosine theta equals 0. And 1 minus 2 sine theta equals 0. Well, whenever it's cosine equals 0 or 1, what you're going to do is draw a picture. There's the cosine curve. And when does it equal 0? Well, it equals 0 here and here. Now remember, this represents 0. This represents 180. It's in the middle. This represents 360. Those are the 3 spots for the middle. The beginning, the end are 0 and 360. The middle is 180. And the other 2 are 90 and 270. So those are 2 of our answers. This one will give us, when you solve for it, you get sine theta equals 1/2. Now, if you don't know that's 30, you just come over to your calculator. You're going to do inverse sine of a half. And it tells you it's 30 degrees. Okay. So I know that 30 degrees, so theta equals 30, but that's your reference angle. Remember, you also have to make a decision which quadrants you're in. And since this is positive, we're going to keep the 30 degrees because we want an angle in the first quadrant. And remember that sine is also, all students take calculus. Remember, sine is also positive here. So we also want an angle in the second quadrant. So come over there and we say that's 30 degrees. So this is 150. So your 4 answers are 90, 270, 30, and 150. All right, kids, moving on. Actually, what I'm going to do now is save, and I'll be right back. So all I'm asking you to do on this page is to decide if it's a cosecant curve, sine curve, cosine curve, whatever, so forth, or the inverses. So we'll go through them quickly. This one should be obvious. It's going to start at a max. It ends at a max. It's got a min in the middle. This one is y equals cosine x. This one is it doesn't go through the origin. And it is just the cotangent curve. Got to know it, kids. This one does go through the origin and goes in the other direction, so this is the tangent curve. Now this one's going to be either cosecant or secant. And the way you determine it is you make points on all the humps. And you connect them. with either what looks like a sine curve or a cosine curve. Now, since it goes through the origin like this, that's the red curve I just drew is y equals sine x. That means this is the reciprocal function of it, cosecant x. So this is y equals cosecant x. All right, this looks like the tangent curve. The tangent curve, remember, looks like this, right? Going through the origin, but on its side. And this is the inverse tangent curve, tan inverse x. Notice this does not go through the origin, but it's one of the weird functions. So it's got to be an inverse function, but it's not going through the origin. The sine curve goes to the origin, so the cosine curve doesn't, so this is inverse cosine x. It's the easiest way to remember it. All right, we're going to connect the humps. Notice it's not going through the origin. It's not going through the origin, so this curve is the cosine curve. So the blue one is the reciprocal function of the cosine curve, or secant x. And finally, we got another little tiny short squiggly thing defined only over a certain interval, and it goes to the origin, and that's the line. That's the equation y equals sine inverse. Remember, inverse functions for sine and cosine are only defined under a short interval or a short domain, so you're always going to have like a little stumpy function. All right. If sine is, you got to know what this means right here. This does not mean less than 0. This means negative. This means positive. So when you get a question like this, all you got to do is do this. All students take calculus. Now you have to remember what this means. You have to remember what this means. This means all are positive. This means sine is positive. This means tangent is positive. And this means cosine is positive. All the regular functions are positive. So, where is sine negative? We're going to put some X marks where sine is negative. Well, if sine's positive up here and here, it has to be negative here and here. Cotangent. I don't know much about cotangent. I don't know much about this cotangent. As a matter of fact, I know a lot more about tangent, which is its reciprocal function. So wherever tangent's positive, cotangent's positive. And tangent is positive here and down here. So the big winner is quadrant 3. What is the domain of the following function? Domain and range. Well, domain for a cosine function is, it just goes on and on and on and on and on and on. So domain for a cosine function is all reals. So this can't be the right answer and this can't be the right answer. It has to be one of these two. So what we need to do is figure out what the range is. That's always the tricky part for these things. So the range is defined, we got the min and max. Min is defined as A minus midline, or excuse me, oh, I'm sorry. Min is defined as the midline minus the amplitude. The max is defined as the midline plus the amplitude. Well, the midline, if you remember, is this right here at the end, 4. So what we're going to do is we're going to take 4 and we're going to subtract the amplitude, which is 2. And I get 2. Then we're going to take 4 and we're going to add 2. And I get 6. So my range is from 2 to 6. Choice 4 is the big winner. Tricky question here. Really what I'm asking you for is this. And this you need to recognize makes you go over to your formula sheet. So come over to my formula sheet. I'm looking for cosine x plus y. That's right here. Yes, it uses A and B. That's cosine A, cosine B minus sine A, sine B. So this thing is really equal to cosine x plus y is really equal to cosine x times cosine y minus sine x times sine y. All right, that's not a problem. So minus. We just got to figure out what these tangs are. Let's see. Cosines, both cosines are n's. Both sines are m's. So this is n squared minus m squared. Done. Convert 1.9 radians to degrees and express the answer to round to the nearest minute. So 1.9 radians. Normally radians have a pi here. And you're like, oh yeah, I multiply by 180 over pi, which is why they always ask these questions on the Regents exam without giving the pi, because you got to remember you still have to multiply by 180 over pi. So the conversion is still to convert from radians to degrees, you have to multiply by 180 over pi. So we just come over to the calculator and we take 1.9, multiply by 180, and divide by pi. And you get 108, blah, 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 blah. Now we need to round that to the nearest, I don't remember, but I know we need to DMS it. So we'll DMS it. And what did they say round to? So I'm going to write down exactly what it is. Answer is 108.51, 108 degrees, 51 minutes, 43 point, oh, they did it, 43.1318. And they want us rounded to the nearest minute. So we have to decide, are we going to leave this as a 1 or are we going to make it at a 2? And in order to determine that, we have to look at this right here. Actually, we just look at the 4, but we're going to look at the 43. If this is bigger than, the cutoff for degrees, minutes, and seconds is 30 seconds. If it's bigger than 30 seconds, we round up, just like in a minute, just like in an hour hand, just like in a clock. Okay, so you need to remember that. That's tricky. So you need to know that the answer here is 108 degrees, 52 minutes. All right, I'll be back. All right, we're back to one of these. Sine of 2 theta, cosine 2 theta. So we have to go to our formula sheet. And we've already used this one again. We're going to use this one again. It just happens to be. We're going to use this one again because they've only given us sine. So we're going to use this. Now, if we remember correctly, it's 1 minus 2 sine squared theta, which we have to write it like this, sine squared theta. Now, be careful. This is negative 1/4. So we'll type this into the old calculator and hopefully get it right. 1 minus parentheses negative 1 divided by 4 squared. Now, this is a common mistake. Let's see if it's even one of the answers. 15/16. Oh, see, if I was doing the test, I'd make that one of the answers. It's a very common mistake that kids make. And they forget the, I think you probably all saw it, you forgot the weird, why is there a 2 there too? And 7/8 is the answer. All right, moving on. All right. Cofunctions, sine, cosine, tangent, cotangent, secant, cosecant, which is what we have here, are equal to each other when their angles add up to 90 degrees. Now, I'm going to guess if you solve this, you'd get 2x equals 14, so you need to end up with x equals 7, which is not the right answer, okay? They're equal to each other when they add up to equal 90 degrees. So what we're going to do is we're going to say, okay, 4x plus 8 plus 2x plus 22 equals 90 degrees. When they equal 90 degrees, the two angles are equal, the two functions are equal to each other. So this is 6x plus 30 equals 90. 6x equals 60, so x equals 10. This doesn't come up often, but you have to know that it will. Arctan. Arctan is the same as tan inverse. So what we have here is the sine of tan inverse of k equals the square root of 3 over 2. All right, so I really just have to plug in these answers. We could plug in 1. I could do this. I'm not going to do this all day. So I could go sine of, let's do this again. Sine, my goodness, you're driving me crazy. Sine, oh, I'm going to crush somebody soon. Sine of tan inverse, oh my gosh, you crazy piece of crap. Alright, so of 1, that was the first one, didn't work. So the answer is the square root of 3. Delete, you hit in radical 3, and you get that. Oh, wait a second. They wanted the square root of 3 over 2. The square root of 3 over 2, that's what they said was the answer, is that. So it's that one. Weird. What is the number of degrees in the angle whose measure is, so again, 7 pi over 5. We're going to multiply by 180 over pi. These cancel. And let's see, 36 times 7, 210. 36 times 7, 210, 252. I'm guessing 252. So 7 times 180 divided by 5. 252. Nice and easy. Which graph is represented by this? All right, so first of all, it's a cosine curve because it's not starting here at the origin, so it's not sine. It's starting down, so it's negative, but they're both negative. And I finished 2 complete sine curves or cosine curves in 2 pi, so there's my answer because the frequency is 2. So I see here we're adding angles. So if I'm adding angles, and I go to my formula sheet again, and basically we're going to use this same formula again. It's cosine, cosine, minus sine, sine. So we'll just do that out. We'll write all that out. It's cosine theta times cosine 90 minus sine theta times sine 90. Well, cosine theta is just cosine theta. But cosine of 90, if you don't remember it, you can put it in your calculator, is really just 0. So this becomes cosine theta times 0. Those go away. Sine of 90, if you don't remember it, is really just 1. So this becomes minus sine theta times 1, which is just minus sine theta. Draw an angle drawn in standard position terminates in quadrant 3 if, I think what they're looking for, an angle A. Angle A has to be greater than 180, or pi, and less than 270 degrees, or 3 pi over 2. Maybe that's all they're looking for. Express the product of cosine 135 and sine 1 in simplest radical form. Crap. All right, so 135. Let's think about where this is. That's somewhere over here. Let's figure out what that reference angle is. If this is 135, if I take 180 and I subtract 135, I get 45 degrees. So this is really the cosine of 45 degrees, which I know is the square root of 2 over 2. But we are in the second quadrant, and in the second quadrant, cosine's negative. Now let's do sine of 300. 300 is down here. That's a reference angle of 60 degrees. So you have to remember that the sine of 60 degrees is radical 3 over 2. But we're in the fourth quadrant, and sine is negative in the fourth quadrant. So to get my final answer, I'm going to take negative radical 2 over 2 times negative radical 3 over 2. And I get radical 6 over 4. Now that appears to be the right answer, right? Looks like it's the right answer. Let me come over here. The square root of 6 divided by 4. You got to learn to check your work. All right, now we're going to check it by doing, I'm not going to use my pen. Doesn't like my pen. Cosine 135 times the sine of 300. Hopefully we get the same decimal. There it is. Perfect. Good check. Find algebraically the measure of the obtuse angle to the nearest tenth of a degree that solve this equation. 3 cosecant theta equals 5. You need to get this all by itself, so we got to divide by 3. Don't forget your simple arithmetic. So I end up with cosecant theta equals 5/3. So we're going to go over to our calculator, and we're going to do inverse, wherever my mouse ended up. Oh, inverse cosecant of 5/3, 5 divided by 3, enter, and I get to the nearest degree, tenth of a degree. So this is 36.9. So theta is equal to 36.9. Now because it's positive, we're going to keep this angle. Now this also goes hand in hand with sine. Where is sine positive? Well, sine is positive in the second quadrant. So in the second quadrant, to find an angle in the second quadrant, you can take 180 minus this. So we're going to do 180 minus this, and we get 143.1. So 143.1. And it said it wanted the obtuse angle. So there it is. Theta equals 143.1, not this one. Prove the following identity. Remember, with proofs, you can only mess with one side. Okay, then. Let's see what we got. Let's see what we got. This is going to be interesting. So, I'm going to just change these. Well, the denominator is 1 plus tangent squared, and I remember that's really just secant squared theta. Got to memorize it. In the numerator, I'm going to change those to sines and cosines. So this is sine of theta over cosine theta times 1 over sine squared theta. I'm going to come through. This cancels with one of these. So in the numerator, I end up with 1 over cosine theta times sine theta all over secant. Now secant is really 1 over cosine squared theta. Well, when you divide by a fraction, the easiest way to divide by a fraction is to multiply by its reciprocal. It's just the way it works. So when we divide by a fraction, we're really going to come through and multiply by its reciprocal. So this is coming up here, and we're going to multiply by its reciprocal, which is cosine squared theta over 1. And we want to make sure that this is going to equal cotangent theta. Well, this, one of these, cancels with one of these, and it leaves me cosine theta over sine theta equals cotangent theta. But you're not done. That last step, you have to remember that cosine theta over sine theta is really cotangent theta is equal to cotangent theta. That's going to be tricky. We got to remember those things. How many more problems we got? Oh, I am not going to finish this morning. All right, prove the following identity. All right, so let's see. I think I'll mess with this side. We're just going to distribute this. But I'm going to first change this to 1 over cosine theta times sine theta over 1 plus cosine theta over 1. And we want to show that this is equal to tangent theta plus 1. So if I distribute, this one gives me sine theta over cosine theta plus this. The cosine thetas cancel when I distribute, so I really just get 1. Does that equal tangent theta plus 1? And this gives me, this thing right here is tangent theta plus 1 equals tangent theta plus 1. So there it is, done. All right, we'll come back. Alrighty, kids, I'm back. I have to save every once in a while. This looks interesting. I remember that cotangent squared theta plus 1, I did the work earlier, is really equal to cosecant squared theta. So I'm going to rewrite it like that. Now, cosecant squared is really 1 over sine squared. So this becomes cosine squared beta times 1 over sine squared beta equals cotangent squared beta. Oops, beta. Now this becomes cosine squared beta over sine squared beta. And we want to show that that's equal to cotangent squared beta. And it is. This is just cotangent squared beta equals cotangent squared beta. Done. Did I record that, I hope? Yes. Express the following as a single trigonometric function. So basically what we're going to do is turn everything into sine and cosine. So tangent is sine of x over cosine of x times cosine of x over 1 all over 1 over sine of x. And I just told you a couple seconds ago, dividing by a fraction is the same as multiplying by its reciprocal, sine x over 1. These cancel. So I end up with sine squared x. Done. Show that it's equal to 1. All right, we're just going to convert them all. Remember, you should be pausing these things and stop watching me. You should be pausing it, try it, and then look. Cosecant is 1 over sine of theta times cosine is cosine theta. Well, this should be x over 1 times sine of x over cosine of x. We want to show that that's equal to 1. Well, I just come through, the cosines cancel, the sines cancel, and I end up with 1 equals 1. Done. Given that an angle is in angle A in quadrant 1 with sine A equal to that, and then B is in that angle. So you need to go back to the formula sheet. Now, why did I do this one again? Cosine A minus B. Oh, this is A minus B is equal to, if you look at the formula sheet, it's cosine A, cosine B, plus sine A times sine B. Now what I'm going to do is I'm going to put some parentheses underneath these. Plus I know that sine A is 12/13. I know that cosine B is negative 3/5. I just don't know what the other two are, so we have to do some work. So let's work with the first quadrant. It said that sine of A is equal to 12 over 13. If you do the Pythagorean theorem, x squared plus 12 squared equals the hypotenuse squared, you end up with x equals 5. So the cosine of A is 5/13. Now we're going to do the same thing with B. But B is in the second quadrant. So cosine is 3 over 5, and this one you should know is 4, and therefore the sine of b is 4/5. So let's see. You just type these all in your calculator. 5/13 negative 3/5. So 5 divided by 13 times negative 3 divided by 5 plus 12/13 and 4/5. 12 divided by 13 times 4 divided by 5. Hit enter. Make sure it's right. Ooh, man, that doesn't look right. Oh, yeah, that's right. 33 over 65. You should use parentheses. I did not. What's the graph of this equation? So the first thing we got to do in this one is find the midline. The bottom is 2. The top is 8. The difference here is 5. So we have to go up half of that, which would be up 2.5. Wait. No, the difference of this is 6. So we're going to go up 3. 1, 2, 3. So our midline is 5. How many of these have a midline of 5? So I know it's one of these. Oh, and then it starts down 3, so it's got to be this one, because this one starts positively up, and ours starts down here, so it's got to be the negative. Boom, done. Which equation has a period of 8 pi? Remember, period is defined as 2 pi over b. Now remember, b is the frequency, and it's always right here. So we'll just go through. 2 pi divided by a half. Dividing by the half is the same as multiplying by the reciprocal, so we're going to multiply by 2 over 1. This gives me 4 pi, not what I wanted. If I did the second one, this would be 2 pi over 2. That would be just pi. That's not going to work. This one's going to give me 2 pi over 1/4 multiplied by the reciprocal, 4 over 1, and there's your answer. 5 radians. Again, you'll notice that every time I ask this question, I'm not giving you 5 pi. If I gave you 5 pi, it'd say, oh yeah, multiply by 180 over pi. But I'm not giving it to you with pi. I'm giving you without pi. But you still do the same math. You're still going to multiply 5 times 180 over pi. Approximately how many degrees? So take out the calculator. 5 times 180 divided by pi. 286.47, so this would be 286 degrees. All right, so convert everything to sine or cosine, so this becomes sine of x over cosine of x. That's the numerator. Secant is 1 over cosine of x. When dividing by a fraction, see how it comes up over and over again. Multiply by the reciprocal, cosine x over 1. Bam. If cosecant of x, all right, remember what this means. This means negative, and this means negative. This is really what we want to talk about is tangent, and this one is sine, so it's a little bit trickier. All students take calculus. Where is sine negative? Ka-ching, ka-ching. Where is tangent negative? Ka-ching, ka-ching. The big winner? Quadrant 4. Period. Period is defined as 2 pi over b. This is b, 1/3. Dividing by a fraction is the same as multiplying by the reciprocal. 2 pi times 3, 6 pi. So we've got cosecant x minus the square root of 2 equals 0. We're just going to solve it, so we're going to bring that square root of 2 over. The next step is to take the inverse of that. Don't want to use this because that causes problems. Inverse cosecant of the square root of 2. 45 degrees. So I know that x equals 45 degrees. Since this is positive, that's one of my answers, 45 degrees. Now, where else is sine positive? All students. Sine is positive in the second quadrant. So in order to get an angle in the second quadrant, I take 180 and I subtract 45 degrees. And I get 135 degrees. That's my next answer. Here we go again. The cosine of 2 theta. So what we're going to do is we're going to use that same formula we used before. Sorry, I got to get rid of my... I got to get a new pen nib. My other one's scratching up my tablet. So we'll get rid of that one. All right. So, and I don't care, but I do. All right. So let's get going. We know that formula that we're going to use is 1 minus 2 sine squared c in this case. So it's 1 minus 2 parentheses squared. Now, what do I put in there? 2/3. So 1 minus that, and then I'll put that in my calculator. Let's see, that's 4/9. That's 8/9. That's 1 minus 8/9. You'll end up with 1/9. If you put it in your calculator, that's what you'd end up with. Which equation is represented by the bottom? So midline is 0, so there's no midline. We're starting up 2, and it's a cosine curve. So it's cosine that's starting positively 2. So that's not these. Now I've got to figure out the frequency. This is the hard part. Remember, frequency is defined as the time it takes to finish one. Frequency is how many of these I'm going to finish in 2 pi. Well, I finish one of these in 2 pi over 3. I'm going to end up finishing 3 of them in 2 pi. Cotangent is equal to tangent when these two add up to 90 degrees. So 3a plus 32 plus 7a minus 12 has to equal 90 degrees. Cotangent and tangent, sine and cosine, the cofunctions are equal to each other when they add to 90. So this is 10a plus 20 equals 90. 10a equals 70, or a is equal to 7. Again, they're equal when they add up to 90. 5a minus 15 plus a plus 21 has to equal 90. 6a plus 6 equals 90. 6a equals 84. A equals 14. Just keep going through these. Simple equations, once you understand the work, the equations are simple. 4x plus 5 plus 3x plus 1 has to equal 90. 7x plus 6 has to equal 90. Wait, did I do this one right? Yes. So this is 7x equals 84. So x equals, I think, 12. And I think this is the last one of these. So we're going to do 10x minus 50 plus 6x plus 20. It's so easy just to put an equal sign in between those and not remember that they add up to 90. So easy. Don't do that. 16x minus 30 equals 90. 16x equals 120. Divide by 16. And my brain's not functioning properly enough for that. 120 divided by 16, and I get 15 over 2, or x equals 7.5. All right, anytime they ask for the exact value, it means you're not going to use your calculator. Baby. So anytime they ask for the exact value, it means you're not going to be using your calculator. Sine of 75. We need to come up with a way to multiply to add up to 75. And you always are going to use 45. So 45 plus 30. Those add up to 70. Now if you go over to your formula sheet, and the sign of two angles that add are sine, cosine, cosine, sine with a plus sign in between. So we're going to do sine of A, or sine of 45, times cosine of B, or cosine 30, plus cosine of 45 times the sine of 30. All right, sine of 45, square root of 2 over 2, times cosine of 30. If you don't remember what these are, put them in your calculator. Do the cosine of 30. I'm not going to do too many of these because my calculator doesn't like it, but do the cosine of 30. 0.5. Oh, wait, cosine of 30. 0.866. So cosine of 30 is the square root of 3 over 2. It's not a half. Plus cosine of 45, square root of 2 over 2, times the sine of 30. Sine of 30 is a half. So you get the square root of 6 over 4 plus the square root of 2 over 4, and your final answer is the square root of 6 plus the square root of 2 all over 4. Two angles that add up to 105. So sine of, again, start with 45. 45 plus, in this case, 60. So we'll do sine 45 times cosine 60 plus cosine 45 times the sine of 60. Well, the cosine and sine of 45 is the square root of 2 over 2. The cosine of 60 is a half. Sine of 60 is the square root of 3 over 2. I end up with the square root of 2 over 4 plus the square root of 6 over 4, which is just equal to the square root of 2 plus the square root of 6 all over this 4. Wow, that's weird. It's the same as 75. That's because they have the same reference angle. Find the exact value of that thing. Well, the first thing I want to do is convert this to degrees. So I'm going to multiply by 180 over pi. The pi's cancel. And if I multiply this out, let's see, that goes in there 15 times. 13 times 15. I don't remember. 13 times 15. 195. So really what I'm asking for is the sine of 195. All right. I know that's going to be the sine of 45 plus something. In this case, it's 150. So now I'm going to use that same formula. It's going to be sine 45 times cosine 150 plus cosine 45 times the sine of 150. Square root of 2 over 2. Square root of 2 over 2. Now, this has a reference angle of 30 degrees. So that the cosine of 30 is the square root of 3 over 2. But it's in the second quadrant, and cosine's negative in the second quadrant. Again, a reference angle of 30 degrees. The sine of 30 degrees is a half. Sine is positive in the second quadrant. So this becomes negative radical 6 plus radical 2 all over 4. 165. So we're going to do cosine 45 plus 120. Now the cosine formula says you're going to do cosine 45 times cosine 120 minus sine of 45 sine of 120. Got to be careful with our signs here. These are just the square root of 2 over 2, square root of 2 over 2. Now, this has a reference angle of 60. The cosine of 60 is a half, but it's negative because we're in the second quadrant. The sine of 60 is the square root of 3 over 2, because we've already done that, and it's positive in that quadrant. So this becomes negative radical 2 minus radical 6 all over 4. All right, kids. I am going to save the rest of this for when I get home. I'm done. Catch you on the flip side, homies. Well, I'm back. That was a long day of school. It's now 6:50 at nighttime. Ooh. All right, here we go. We only got like 11 or 12 questions left. I know this is a long video. Hopefully you downloaded the sheet and you're like looking at the problems. If not, go to my website. We'll talk about it. Anyway, cosine 345, I want the exact value. Now, exact value means, and I don't know if I mentioned this before, that you cannot use the calculator. So what you have to do is our memory. So cosine of 345. I somehow have to make 345. Well, it's got a 45, so we'll start with that, plus 300. Now, you know you can use this because, well, 45 you're just definitely going to use, but this has a reference angle of 60 degrees. So that is a good angle to use. So the formula for cosine, if you've forgotten, we're adding. So remember, it's got the opposite sign here. So it's going to be cosine, cosine, sine, sine, but with an opposite sign. So it's cosine 45 times cosine 300 minus sine of 45 times the sine of 300. Well, the sine of 45 and the sine of 45 and the cosine of 45 are both the same. They're both square root of 2 over 2. 60 degree angle, cosine of 60 is 1/2. In the fourth quadrant, all students take cosines positive. But sine is negative down there, and the sine of 60 degrees is the square root of 3 over 2, but it's negative. So my answer is the square root of 2 over 4 minus, wait, hold on. We got a minus here. It's minus negative square root of 6 over, all right, so I probably should have done this slowly. Hold on. So, come on, get off my screen. It'll go. So this is the square root of 2 over 4 minus negative square root of 6 over 4. Well, this becomes the square root of 2 plus the square root of 6 all over 4. That's it, bros. All right, remember, got to look at your formula sheet, and we were given cosine. So if we go over to our formula sheet, this is the one that was, if you're given cosine, you want to use this one right here. All right, so it's 2 cosine squared a minus 1. So 2 cosine squared a minus 1. And again, I know I talked about this earlier, but cosine squared a is really cosine of a squared minus 1. So what we're going to do is we're going to take this, which is 8 over 17, and we're going to put it right in there in that parentheses. Well, we just grab our calculator and type it in. Not that. 2 parenthesis 8 divided by 17 squared, don't forget the squared, minus 1. And you get negative 161 over 289. Negative 161 over 289. 48. We're working backwards. Sometimes they ask you things backwards. So I see 1 minus 2 sine squared, I'm going to say of an angle. This is my angle. So there's my angle. So this, if you look carefully, this is really this formula right here. Do you see the 1 minus, do you see this 1 minus 2 sine squared here? So that's really cosine of 2a. So if I come back to my sheet and I say, okay, that's really just the cosine of 2a. Well, what was my a? Oh, a was pi over 6. So this is really the cosine of 2 times pi over 6, which is really just the cosine of 2 pi over 6. But pi over 6 is really, 2 pi over 6 is really pi over 3. So this is really equivalent to the cosine of pi over 3. Now, that's not good enough because it said find the exact value. Let's see, pi over 3, if I want to convert that to degrees, do 180 divided by pi, the pi's cancel, and I end up with 60 degrees. So really what they're asking me for, in effect, is what's the cosine of 60 degrees? Because this is really just 60 degrees. And the cosine of 60 degrees is 1/2. Ka-ching. So I'm looking at this thing right here, and I see cosine, cosine, plus sine, sine. Now, I'm pretty sure that's one of my formulas. Cosine, cosine, sine, sine. So if you look down onto your formula sheet, you see cosine, cosine, plus sine, sine. Is that what I have? Yep, I have cosine, cosine, plus sine, sine. Well, that formula is cosine of the first angle minus the second angle. So this is really equal to, or equivalent to, cosine of A minus B, where this is A and this is B. So that's 50 minus 30, which is 20. All right, here we go, sisters and brothers. All right, now come the hard problems. These are probably 4 to 6 point questions that you're going to get. So, what do we got going on? We got this double angle formula right here. Double angle formula right there. Cosine of 2 theta. Well, I got to replace that. But if I look over here, all I see are sines. So I want to stick with that. And I go to my formula sheet. And I said, I need the one with just sine in it. So I need the cosine 2a with just sine in it. I just actually erased it. There it is right there. That's what I need. 1 minus 2 sine squared a. So I'm going to come back. I'm going to replace that. I'm going to replace this. I'm going to get rid of it. And I'm just going to put 1 minus 2 sine squared theta plus sine theta equals sine squared theta minus 1. Well, I don't want to have a negative. See how this is negative here? I don't want to have a negative sine squared. So I'm going to add 2 sine squared. I'm going to move everything over to the right. So plus 2 sine squared theta. And then this is going to go over and become negative. And then I'm going to subtract this 1 and subtract this 1 and bring this over. So I end up with this 0 equals 3 sine squared theta minus sine theta minus 2. Well, that I have to factor. I have to factor that. So I can either cheat, but I'm not going to. I'm going to do it the right way, but I am going to check my answers. So 3 sine theta and sine theta. And I got to get negative 3. So this is going to be negative 1 and this is going to be positive 2. So my two answers are going to be sine theta equals negative 2 over 3 and sine theta equals 1. But just for fun, I want to make sure I got that right. Keep hitting the wrong button. Menu 331, menu 331. It's a quadratic. And my coefficients are 3, 1, and negative 2. Actually, it's negative 1. So I'm going to go 3, negative 1, negative 2, hit OK, OK. And my two answers are negative 2/3 and 1, and negative 2/3 and 1 is what I got. Well, I'm not done yet. I still got to figure out what theta is. So for this one, we're going to do inverse sine of positive 2/3. So we're going to do, let me put these over here so we can see them. So we're going to do cosine of theta is equal to negative 2 over 3. And cosine of theta equals 1. So this one I'm going to put in my calculator. You have to. So inverse cosine of 2 divided by 3. Notice I did not put the negative in. You do not put the negative in. You get that angle. Wait a second. Round answer to the nearest minute. Doggone it. I got to put. So I got my answer. But, so I get theta is equal to 48.189. 48.189. I know that's not rounded to the nearest minute, but I got to decide whether or not I want to keep it anyway. So I'm looking at this negative and I'm thinking, okay, wait a second. If this is negative, you never ever keep the angle. So I don't want this angle, but I do need to figure out where cosine is negative. So all students take calculus. Cosine's positive here and cosine's positive there. So I need an angle in the second quadrant and I need an angle in the third quadrant. Well, to find the angle in the second quadrant, we do 180 minus this. To do the find angle in the third quadrant, I do 180 plus this. All right, so 180 minus this equals. Now is when I'm going to DMS it. So I go into my catalog and I DMS this thing. 131, 48, 37. I'm going to write that all down. Theta equals 148 degrees 131 degrees, 48 minutes, 37 seconds. I'll round that later. And then I'm going to do 180 plus this. And I get 228, but I got to DMS it. I forgot to DMS it. So 228, 11, 22. So 228, 11, 22. Now I got to decide. I got to round this answer to the nearest minute. Well, this is the nearest minute right here. And I got to look at this 37. Remember, 30 is the cutoff for rounding. So yes, I have to round this thing up. So 131 degrees, 49 minutes. The other one is 228 degrees, 11 minutes, because this is 22. It's less than 30. Now cosine equals 1. Let me draw the picture for cosine equals 1. Anytime you got 1 or 0, you draw the picture. Remember, this represents 0. This represents 90. Halfway through is 180. Next one is 270. And all the way through is 360. So where does cosine equal positive 1? At 0 and 360. Now I got to decide if I can keep 360. Notice over here it says equal to 360. So we can keep that one. So my two answers are going to be now, my two final answers are going to be 0 degrees and 360 degrees. There's my 4 answers. All right. I see a double angle formula again. Bam, there it is. I got to go to my formula sheet. Where is it? It's right there. I got to use that formula right there. Sine of 2a is 2 sine a cosine a. So I'll grab up my calculator. Oops, wait. How long have we been going for? We got time. So this is 2 sine theta cosine theta minus cosine theta equals 0. Well, you're not really supposed to factor if you've got more than one trig function that there aren't the same. However, I have a GCF, and you can always take out a GCF. So in this case, I'm going to take out a GCF, cosine theta times 2. Now, if I take that out, gone and gone. But don't forget, there's still a 1 right here. There's still a 1 there. Lots of kids forget that. It's 2 sine theta minus 1 equals 0. Well, I'm going to set these things equal to 0. Cosine theta equals 0. And 2 sine theta minus 1 equals 0. So minus 1 equals 0. This one I'm going to draw a picture for. It equals 0 at 90 and 270. So those are my first two answers. 90 degrees, 270 degrees. And then this one ends up with sine theta equals 1/2. And hopefully by now you've memorized that that's 30 degrees. And it's also positive in the second quadrant at 150 degrees. Remember, you go to the second quadrant, 30 degrees, you take 180 minus the reference angle, which is 30, and you get 150. All right, I'll be right back. You won't even know I'm gone. Thanks, Dunkin' Donuts. I'm running on you. I think that's what it says. You run on Dunkin' Donuts? I don't know. You down with OPB? Yeah, you know me. What am I doing here? All right, where am I going? Oh my gosh, I got so much more to do. We're in good shape, though. All right, cosine 2 theta. We talked about it before. We're going to replace it. And we're going to replace it, in this case, with 1 minus 2 sine squared theta. I feel like I've done this problem already. Cosine 2 theta plus sine theta. I did. So we're going to skip that problem. So here we go. Now we got another issue. I've got a squared, cosine, and a sine. I can't do that. But there's no formula on the formula sheet to figure out what I got to replace. Now the thing is, the rule of thumb is, if it's got a 2, whether it be a sine squared theta, a cosine squared theta, a secant squared theta, a cosecant squared theta, or a sine 2 theta, or a cosine 2 theta, it can be replaced. it can be replaced. Now, in order to know this one, you have to go back to the fact that sine squared theta plus cosine squared theta is equal to 1. Well, if that's true, and I bring this over here, I get sine squared theta is equal to 1 minus cosine squared theta. And that's the replacement you have to make. That's what's going in here. So we're going to do 2 parentheses plus 5 cosine theta minus or plus 5 equals 0. And I'm going to replace that sine squared with 1 minus cosine squared theta. And now I can solve it because now I have only cosine. And that's the trick. You only have cosine. So we'll distribute. We get 2 minus 2 cosine squared theta plus 5 cosine theta plus 5 equals 0. Now everything has to go to the right because my squared term is negative, and that's not good. So we're going to move everything to the right. So I get 0 equals 2 cosine squared theta minus 5 cosine theta. Now this 5 and this 2 make 7, so minus 7. Ooh, that looks like tough factoring to me. So we're going to do 2 cosine theta and cosine theta. And it's really just minus 7 and plus 1. So my two answers are cosine theta equals 7 over 2 or cosine theta equals negative 1. Now I want to check that because this is going to be a problem. So let me just check that. I'm going to menu 331 that. So menu 331. It's a quadratic, and my things are 2, negative 5, and negative 7. So 2, negative 5, negative 5, negative 7. Click OK, click OK. Yeah, there it is. Negative 1 and 7/2. This one's no good. This one's no good. Now, if you tried it on your calculator and you said, okay, I'm going to do inverse cosine of 7 divided by 2, it's going to crash. It's going to say not a real number. Not going to work. So that doesn't work. As far as for 1 goes, we're going to draw the picture. And really we're looking for when does it equal negative 1. Well, remember, this is 1. This down here is negative 1. So it equals negative 1 right there, right in the middle at 180 degrees. So all of that work just to get 180 degrees, and that's your only answer. Man. All right, so even though these are all cosine, you still are not allowed to work with a double angle. You have to replace it. So we're going to replace it with the one that makes sense, the one with all cosine in it. This one right here, all cosine in it. So it's going to be 3, 2 cosine squared theta minus 1. And now we'll just copy everything down. Plus 17 cosine theta equals 0. So I get 6 cosine squared theta minus 3 plus 17 cosine theta equals goose egg. Now I got to put it in the right form because this, you know, the cosine's got to come second. You can't have this constant right here in the middle. So 6 cosine squared theta plus 17 cosine theta minus 3 equals 0. And I always get the kid that says nothing multiplies with negative 3 that adds up to 17. Really? Because you got this big ass 6 in the front. So I'll do the factoring, and then I'm going to check it using menu 331. It's 6 cosine theta and cosine theta. Got it? Got it? Plus 3 minus 1. This gives me 18. This gives me negative 1. So my two answers are cosine theta equals 1/6 and cosine theta equals negative 3. And we just talked about the fact it can't be bigger than 1. So that one's got to go. I know you all don't believe me, so we're going to do it. Menu 331. It's a quadratic. 6, 17, negative 3. 6, 17, negative 3. There it is, negative 3 and 1/6. Got it. All right, so I got to figure out when cosine equals 1/6. Now that's positive. So let's see, inverse cosine of 1 divided by 6. And I get 80.405931. So theta equals 80.405931. I am going to keep this because cosine's positive in the first and fourth quadrant. So I'm going to get the other one by doing 360 minus 80.405931. But I also got to decide how they want me to round this sucker. Rounded to the nearest degree, fantastic. So my two answers are going to be 80 degrees and 360 minus 80, which is 280. All right, I think I got to save and I'll be right back. This might be the last group. Let's go, let's go. All right, I told you a couple minutes ago, if it's got a squared, it can be replaced. Now, this is one you have to have memorized. You need to know that cotangent squared plus 1 is equal to cosecant squared. You're not going to find it anywhere. You just have to know it. So this is cotangent squared theta plus 1. Now that replaced this. Now I'll copy everything else down. Plus cotangent theta minus 7 equals 0. Now once you know that, the problem's not bad. Actually, it's a relatively simple question. Not cosine. Cotangent squared theta cotangent squared theta plus cotangent theta minus 6 equals 0. I've got to combine the 1 and the negative 7. Factoring is quite simple here. It's cotangent theta plus 3 and minus 2. So I end up with cotangent theta equals 2 and cotangent theta equals negative 3. Now we've got some issues. First of all, the only ones that can't be bigger than 1 or less than 1 are sine and cosine. So these are okay, but I have to think about what quadrants we're in. So for cotangent, we're really worried about tangent. So all students take calculus. Tangent is positive here and here, but negative here and here. So in this one, I'm going to get quadrants 2 and 3. And this one, I'll get quadrants 1 and 4. All right, so let's do this. Inverse cotangent of 2. Now I got to figure out what they want me to round to. It doesn't say, so we're going to round to the nearest degree just to make our life easier. 27 degrees. So theta is equal to 27. We're going to keep it, and then we're going to also add 180 to it. So the other angle will be 180 plus that, which would be 207. Now we're going to do this one. Inverse, let's put it up like this. Inverse cotangent of negative 3. Oh, we don't put in the negative. Don't put in the negative. Just 3. And I get 18 degrees. So theta equals 18. But I'm not going to keep it because I need a quadrant 2 angle and a quadrant. Whoa, let's back up to. No, I don't need a quadrant 3. I need a quadrant 2. Oh, this one messed up. This one is cotangent is positive in quadrants 1 and 3. And negative in quadrants 2 and 4. Screwed that up. Sorry about that. So I don't want this angle. I want 180 minus this. That would be 162. And fourth, I want 360 minus 18, which would be 342. So my four answers are 27 and 207. That's the first and the third quadrant. And then 162 and 342. That would be in the other two quadrants. How many got? 56, 57, 58, 59. 4 questions. Man, this is the video that never ends. It goes. Okay. Sine of 2 theta. We've already talked about replacing it. You should know what to replace it with. By the way, probably a good idea if you haven't paused in a while to try one on your own. Cosine theta minus 2 sine theta cosine theta equals 0. I've got a GCF of cosine theta, so I'm going to take it out, and I'm left with, don't forget, There's a 1 here. So even though you're taking out the cosine theta, there's still a 1 here. So 1 minus 2 sine theta equals 0. So this gives me cosine theta equals goose egg, and this one gives me sine theta equals 1/2. I've already had these answers before. Cosine equals 0 at 90 and 270. So those are two of my answers, 90 degrees and 270 degrees. Oh my God, it's so much fun. Especially when I have Dunkin' Donuts coffee. I know I'm going to convince a few of you to drink coffee, and then you're going to be like, oh my God, I never stopped drinking coffee. That's why I'm so wired. That guy's crazy. I'm up at 4 o'clock in the morning doing math. If you're up at 4 o'clock in the morning doing math, you got some problems. Let's do inverse sine of 1/2. We know that's 30 degrees, and that's 30 in the first quadrant, and in the second quadrant we would get 180 minus 30, which would be 150. So those are my two other angles, kids. You're like, oh my God, I wish I could do math as good as Mr. Krause. All right, nearest minute. We're going to do nearest minute. So I got to replace a squared. And again, this is just one you need to know, that secant squared x is really equal to tangent squared x plus 1. So I'm going to replace it. 6 tangent squared x plus 1. That's what went in place for this. Minus tangent x equals 11. So I get 6 tangent squared x plus 6 minus tan x equals 11. Let's put everything on the left side and put everything in order. So I get 6 tangent squared x minus tangent x. Now we're going to bring this minus 11 over, and I get minus 5 equals 0. So the factoring here might be tough. Let's just menu 331 it. When I'm done, I should end up with tangent theta equals something, and tangent theta equals something. So we'll do inverse. Let's go. Menu 331, enter. 6, -1, -5. 6, -1. Doesn't sound like it's going to work. -5. Not bad. -5 over 6 and 1. -5 over 6 and 1. Well, this one's easy. It's just tan theta minus 1, because that's what would give me this. Now, if this wasn't here, I would have tan theta plus 5. But this 6 is there, and that 6 goes out front. There's my factoring. Now I've got a little bit of work to do. So this is -5 over 6. So tangent is negative in the second and fourth quadrant. So when I find this, I'm not going to keep the answer. I want to find the answer in the second and fourth quadrant. So inverse tan of 5 divided by 6. Notice I didn't put the negative in. It's just going to tell me. Now I got to round. I'm going to end up rounding this nearest minute, but I want to get my angles first. So I'm going to do 180 minus that. 180 minus this equals, and then we'll DMS it. So to the nearest minute, notice it's 39 right here, right? 39, right? That means we round up. So 140/12, 140 degrees, 12 minutes. Now I need to get the one in the fourth quadrant, so I'm going to do 360 minus this, enter, and I'll DMS it all at the same time. 360 minus this, and DMS. So I get 320/12. So 320 degrees, 12 minutes. So now I'm going to do tangent theta equals 1, and I know that's 45 degrees. If you don't know it, do inverse tan of 1, you get 45 degrees. And in the third quadrant, it's 225 degrees. All right. I've got 2 problems left. I'm going to pause. I'll be right back. If you haven't paused it in a while, you might want to, okay? Try something on your own. I'll give you a hint. This has to be replaced. So, Oh, you're back. Oh, my God. It's so good to see you. So here we go. Cosecant theta squared theta. Oh, my God. We're using x. Stop with the thetas. Is equal to cotangent squared theta plus 1. Use your hints. It's got to be cotangent. It's got to match that. So we're going to replace that. So I get 8. I'll replace it. Plus or minus 3 cotangent theta equals 13. So what am I going to replace it with? That's ugly. I'm going to replace it with cotangent squared theta plus 1. All right. So 8 cotangent squared theta plus 1 plus 8 minus 3 cotangent theta equals 13. If I clean everything up and bring it to the left side, I get 8 cotangent squared theta minus 3 cotangent theta. Now, I'm going to subtract this 13. So I get minus 5 equals 0. All right, this factoring looks funky. So maybe I'll just cheat. Cotangent theta equals cotangent theta equals. Hold on, let me do it in my head. So it's going to be 8 cotangent theta and cotangent theta plus 5 and minus 1. So my two answers are going to be negative 5 over 8 and 1. But you don't believe me, do you? So menu 3, 3, 1, enter 8, negative 3, negative 5. 8, negative 3, negative 5. There it is. Negative 5 eighths and 1. Negative 5 eighths and 1. So cotangent theta equals 1 at 45 degrees and 225. It's the same as tangent equal to 1. It's just this one I got to mess with. So I'm going to do the inverse cotangent of 5 eighths. 5 divided by 8. Notice I didn't put the sign in. I get 57.9946. What do they want us to round on this one? Nearest minute. So I'm not going to keep that one, but I want the ones in the second and fourth. So I'm going to do 180 minus this crap. And then I'm going to DMS it. And it's set to the nearest minute. So this would be 122 degrees, 0 minutes. So 122 degrees, 0 minutes. You have to put the 0 in. And then 360 minus this. And then we'll DMS that as well. And this would be 302 degrees. This comma shouldn't be here. So 302 degrees, 0 minutes. And the other two are 45 degrees and 225 degrees. All right, we're on the last problem. So we're going to replace secant squared theta. Secant squared theta, we've already determined, is tangent squared theta plus 1. Equals 5 minus tangent theta. Distribute the 2, I get 2 tangent squared theta plus 2 equals 5 minus tangent theta. Everything's got to come to the left side, so our squared term's positive. Plus tan theta. And then it'll be minus 3 equals 0 because you're going to subtract 5. So I got a factor. Factoring's easy. It's 2 tangent theta and tangent theta. And I need a plus 3 and a minus 1. Yep. So my two answers here are going to be tangent theta equals negative 3 over 2 and tangent theta equals 1. By now you know this one's 45 and 225. It's cotangent and tangent for 1 is the same. Here we got to figure out what that is. So we're going to do inverse tan of 3 halves, not negative, 3 divided by 2. And we got to round to the nearest. We're going to end up rounding to the nearest minute. So I don't want this one because it's negative, so I'm going to do 180 minus this. And DMS it. So that's one, remember, 30 is the cutoff, so not 24. So 123.41. So 123 degrees, 41 minutes. And we're going to do 360 minus, oops. So we're going to do 360 minus this. And we'll DMS that as well. And we get 303.41. 303 degrees, 41 minutes, 45 degrees, and 225 degrees. Holy mackerel, that took forever. I think that's it. I hope that's it. My goodness, that's going to be like 3 review sessions. So don't do it all at one time. I hope you enjoyed yourself. Psh, yeah, right. Hit the subscribe button. Yeah, right. I'm done with this crap. Hit the like button. Yeah, I didn't like that. It was painful. It was like sticking a dagger in my eye, bro. I hope you learned something. All right, peace out.